Dear students, we are still on coordinate geometry 1. Today we are going to produce video number 8 with this example. I read find the equation of the perpendicular to the line 2y plus 3x is equal to 6 through the point 5, 2 and the coordinate of the foot of the perpendicular. Calculate the distance of the point. Calculate the distance of the point. The distance of the point 2, minus 3 from the line 2y plus 3x is equals to 6. This is the question. This is the question. Solution. Solution. Now we are required to find the equation of the perpendicular to this line. Equation of the perpendicular to this line. For better visualization, we can sketch this line. Now you are given the line 2y plus 3x is equals to 6. If you make y the subject of the formula, yes, the question is correct. If I make y the subject here, it's just to know the shape of the. So making the y the subject, so I'm going to have y. Yes, y is equals to, or 2y first, 2y is equals to minus 3x plus 6. So y is equals to minus 3 over 2x plus 3. 6 by 2 is 3. So you can see the slope of this line is, here, the slope of the given line, is minus 3 over 2. So now if this is the line, for instance, if the slope is minus 3 over 2, it means the line is sloping downwards. I sketch it like that. This is the given line. That is the given line 2y plus 3x equals 6. That is the given line. Now the question says we should find the equation of the perpendicular to this line. A perpendicular to this line will be a line drawn that will make an angle of 90 degrees with the line. So if this is line L1, then this can be line L2, the second line, which is perpendicular. That is the symbol that is perpendicular, an angle of 90 degrees. And we are told that this perpendicular, now the question says find the equation of the perpendicular to the line 2y plus 3y equals 6 through the point 5, 2. This perpendicular line is passing through a point, call it point P, 5, 2. That is what the question is saying. Now, we are also to calculate the coordinate of the foot of the perpendicular. Let the foot of the perpendicular be F. This is the foot of the perpendicular. The point of intersection of the two perpendicular lines is known as the foot of the perpendicular. So let us use F. We are to calculate the coordinate of this F. And then, again, we are also to calculate the distance of the point 2 minus 3. Point 2 minus 3 is somewhere from this line, from this very line. Point 2 minus 3 is maybe somewhere down here. So calculate the distance of that point from this line. question before us. This is the question before us. Now we are told that this line L2 is passing through point P whose coordinates are 5, 2. We are to find the equation of line L2 or line PF. Now we know that slope of the given line L1 is equals to minus 3 over 2. It's already found here. Therefore, slope of the perpendicular, please, this is the symbol of perpendicular. This is the symbol of perpendicular. Slope of the perpendicular line L2 will be minus 1 over the slope of the other line, which is minus 3 over 2. Minus will cancel minus. These two move up, and that will be 2/3. So the slope of the perpendicular line L2 is 2/3. Therefore, equation of the perpendicular line L2 through the point P52 is, we use the point slope form. Point slope form in the sense that we know the slope of the perpendicular, which is 2 over 3, and we know the coordinate of a point on that line. So we use the point slope form. It's going to be y minus y1 is equals to m into x minus x1, i.e. y minus y1 in this case is 2. Is equals to m. M in this case is 2 over 3 into x minus x1 in this case is 5. That's 5. So now I can clear the fraction. Multiply 2 by 3. I have 3 into y minus 2 is equals to 2 into x minus 5. Expand. I have 3y minus 6 is equals to 2x minus 10. So I have 3y is equals to 2x minus 10 plus 6. Therefore, 3y is equals to 2x minus 4. So this is the equation of the perpendicular. This is the answer. You can call this one equation 1. Now, you can call that one equation 1 just for reference. So the next question is, we should calculate the coordinates. We should also calculate the coordinate of the foot of the perpendicular. We should calculate the coordinate of this foot of the perpendicular, which is point F. How do we determine the coordinate of this point F? Since these two perpendicular lines are meeting at point F, we solve the two lines simultaneously. Now this given equation is 2y plus 3x is equals to 6. This we are given. Now, so from here, that is 2y. I can rewrite it as 3x plus 2y equals 6. So now let me call this one equation 2. And this equation 1, I can rewrite it as 2x. This 3y, okay. Anyway, in equation 1, I have 3y is equals to 2x minus 4. I can rewrite this. I can take minus 4 this side and then 3y this side. So I can have 2x minus 3y is equals to 4. Is equals to 4. So that is what I'm doing. This is equals to, yes, equals to 4. Now, this is my equation 1 here. Equation 1. This equation 2 is 3x plus 2y is equals to 6. Equation 2. I have to solve these two equations simultaneously. So what do? You all know how to solve simultaneous equation. Multiply equation 1 by equation 1 times 3 and equation 2 times 2. If I do that, I am going to have so equation 1 times 3. Equation 1 times 3 means that we are going to multiply each and every term of that equation 1 by 3. And if you do that, I'm going to have 6x minus 9y. Yes. So, okay.
Equal to 12.
Eh?
Equal to 12.
Okay. Yes. So minus 9y is equals to 12. Equation 2 by 2 means that each and every term of equation 2 multiplied by 2, that will be 6x. 6x plus
4y.
Plus 4y is equals to
12.
12 also?
Yes.
Okay. So it's equals to 12. Good. Now, if I'm going to, because since the coefficient of x are equal, both in sign and now I can take this 6x from 6x. That will be 0. 4y minus 9y, that will be minus 13y. In other words, minus 9y minus 4y minus 13y is equals to 12 minus 12, 0. Or y equals 0 over minus 13, which is still 0. So, substitute for y in either equation 1 or 2, any of them. Substitute for y in equation 1. If I substitute that, I'm going to have 2x minus 3 into 0, because y equals 0 here is equals to 4. Is it not?
Yes.
Yes. So, it means, now, this will give me 0. So, 2x is equals to 4, or x equals 2. Therefore, the foot of the, now I'm answering the question, the foot of the perpendicular f is equals to 2, 0. That is the foot of the perpendicular. Now, next, we are to calculate the distance of a point, from a given line. The distance of a point from a given line. So, calculate this. So the distance of a point from a given line, and from which line are we to, that is, we are now to find, we are to calculate the distance the distance of the point 2 minus 3 from the line 2y plus 3x is equals to 6. That is the question. So what do I do? First, that is solution. We first rewrite the given equation. 2y plus 3x equals 6 in the general form. Ax plus by plus c is equals to 0. i.e. 2y plus 3x equals to 6 can be written as 3x plus 2y, take this 6 across, minus 6 is equals to 0. Now, if you compare this equation with this, they look alike. So by comparison, the coefficient of, in the general form, the coefficient of x here is a, and in the given equation, the coefficient of x is 3, so a is 3. The coefficient of y here is 2. If you compare it, so b is equals to y. That is, yes, b is equals to 2. And c here is the constant. C equals minus 6. Now, what point are we getting? Here, we say let x1, y1 be equals to that point, which is 2 minus 3. So, we use our formula. There's a formula for calculating the perpendicular distance from a given line.
Yes.
From a given line. If D is the perpendicular or shortest distance of a point x1, y1 from the line ax plus by plus c is equals to 0, then my d is equals to the absolute value of ax1 plus by1 plus c over the root of a square plus b square. This is the formula for calculating the shortest distance of a point from a given line. So my b, a in this case is
3.
A is 3. A in this case is 3 times x1. X1 is 2 plus b is what?
2.
2 into y1. Y1
is y1.
This is y1. Minus 3. Y1 is minus 3 plus c. C is minus 6
minus 6
over the root of a square.
3
A is 3 plus b squared.
2 squared.
So that is 2 squared. 2 squared. So d is equals to the absolute value of that is 6. 2 minus 3 6 plus minus 6 over the root of 9 plus 4. So this. So I'm left with the absolute value of minus 6 over the root of 13. So my d now, my d is equals to, the absolute value of a negative number is positive, so that is 6 over root 13 units. Root 13 units. Or if I rationalize it, I can leave it like this, that is units. That is my answer. That is my answer.